So part of the issue with diabetes is not producing or not releasing enough insulin into the bloodstream to help lower glucose levels in the bloodstream. So in this video I'm going to go over basically how our body, what causes our body to release insulin into the bloodstream. Okay, so insulin is actually stored as insulin granules in these beta cells. And these beta cells are found in the pancreas in the inlet of Langerhans. So it's these beta cells that store these insulin granules, which are basically packets of insulin, which is a peptide hormone. So what happens, we eat a starchy meal, and it eventually gets broken down to glucose here that I have in the purple triangle. And when we have enough glucose in our bloodstream, it'll eventually get to the pancreas. So this glucose-rich blood will get to the pancreas, and then it will bind, it will get passed into these beta cells through this GLUT2 receptor. So when the glucose enters into the beta cells through the GLUT2 receptor, it's actually a phosphate molecule is added to the glucose by an enzyme called hexokinase 4. Now once that happens, this glucose with the phosphate molecule can then enter a process called cellular respiration, which happens in the mitochondria. And as a result, glucose is broken down completely into water and carbon dioxide, so in ATP, which is what cellular respiration really does, is it produces our energy for us. So glucose with the phosphate, again, is broken down into water, carbon dioxide, and ATP. Now each ATP molecule that's produced from one molecule of glucose has 3 phosphate atoms, which are 3 phosphate molecules with 4 oxygen atoms attached to them. So again, in these beta cells, once the beta cells produce enough ATP through cellular respiration, the ATP is going to come over and block this potassium-gated channel. Now, when the potassium-gated channel is not blocked, potassium leaves the cell. But when ATP gets to a certain level, an ATP molecule will actually block this potassium-gated channel and prevent potassium from leaving the beta cells. And as a consequence, it allows calcium at that point to enter into these beta cells. And what these calcium atoms do is they push these insulin granules out of the cell, and they release the insulin hormone into the bloodstream. So that's basically how the overview of how these beta cells actually release insulin. So what I wanted to highlight here is what we need to take with our starchy meals, or in overall. First of all, this is all driven by protein. These hexokinases, that's a protein. It's an enzyme, and this whole cellular respiration process is driven by vitamins, minerals, and protein. So I went over how we convert glucose into ATP in my Diabetes Part 1 video, and I'm not going to go over that again here, but you need your protein, vitamins, and minerals to turn glucose into our ATP, which is going to help release our insulin. Insulin is a hormone, but it is made from a protein, so you're going to have to take protein to get enough insulin. And then again, we're going to need our potassium. Our RDA for potassium is roughly 4,700 milligrams, or in my opinion, it's more like 3 milligrams of potassium to every 1 milligram of sodium. But generally, people ballpark it as about 4,700 milligrams. You're also going to need your calcium here. About 1,200 milligrams is roughly the RDA for adults. And then phosphorus, which is often not talked about when considering vitamins and minerals, but you're going to need phosphorus. It's one of the most abundant elements in our body, which is only surpassed really by oxygen, hydrogen, and carbon. So phosphorus is very high. We need, and it's estimated, I just went to the Linus Pauling Institute page and they say about 700 milligrams, I think. That's where I think I got it. But anyways, so you're going to have to look and see if you're getting enough phosphorus, calcium, potassium, and then it's speculated that chromium is a cofactor for the insulin hormone. So a cofactor and coenzymes, to put it bluntly, is these cofactors and coenzymes help the protein or peptide or hormone function properly. So you're going to have to look at trying to get enough chromium or to see where you're getting it in your diet. Alright, so that's how we release insulin into the bloodstream. You need your potassium, your calcium, you need phosphorus for this process here, and please watch my Diabetes Part 1 video if you're interested in seeing everything that's required to turn glucose into ATP.